Today we'll be doing the integral from 0 to 1 of 1 divided by 1 plus the floor of 1 over x dx. And to start off, we'll make a substitution. So we're going to let u equal 1 over x, which this means that x equals 1 over u. That also means that dx is negative 1 over u squared. And as for the bounds, u1 will be 1 over 0, which is approaching positive infinity. u2 will be 1 over 1, which is 1. So we have the integral from infinity to 1 of 1 over 1 plus the floor of u, and dx is negative 1 over u squared du. We could use the negative to flip the bounds of integration. So you have the integral from 1 to infinity of 1 over the u squared of 1 plus the floor of u, and then du. And then from here, we can rewrite the integral as the sum from 1 to infinity of the integral from k to k plus 1 of 1 over u squared times 1 plus the floor of u du. And we'll make the observation, since u is in the integral from k to k plus 1, then this means that the floor of u is equal to k. So we have the sum from 1 to infinity of the integral from k to k plus 1 of 1 over u squared times 1 plus k du. We could factor the 1 over 1 plus k factor. So we have the sum from 1 to infinity, 1 over 1 plus k, and it times the integral from k to k plus 1 of 1 over u squared du. So we're going to have the sum from 1 to infinity, 1 over 1 plus k. This integral will evaluate to negative 1 over u from k to k plus 1. So we're going to have the sum from 1 to infinity of 1 over 1 plus k. We're going to have times negative 1 over k plus 1 and plus 1 over k. So distributing that, we have negative the sum from 1 to infinity of 1 over k plus 1 squared, and then plus the sum from 1 to infinity of 1 over k times 1 plus k. So we're going to do this sum first. We know that the sum from 0 to infinity of 1 over k plus 1 squared is the same thing as pi squared over 6. So this means that the sum from 1 to infinity of 1 over k plus 1 squared would just be pi squared over 6 minus the first term, which will be 1. So we're going to have a negative pi squared over 6 minus 1 plus the sum from 1 to infinity 1 over k times 1 plus k. So we have a minus pi squared over 6 plus 1 and plus the sum from 1 to infinity of 1 over k times 1 plus k. And we can use partial fractions decomposition. So we're going to have a over k plus b over k plus 1 is the same thing as 1 over k times 1 plus k. So this means that a times k plus 1 plus b times k is equal to 1. And expanding that, we have ak plus a plus bk equals 1. So factoring out the k, we have k times a plus b plus a is equal to 1. So this means that a plus b must be 0, and a must equal to 1. But if a equals 1, that means that b plus 1 equals 0, which means that b equals -1. So we have a 1 over k minus 1 over k plus 1 equals 1 over k times 1 plus k, which is the sum end. So we have a minus pi squared over 6 plus 1, and then plus the sum from 1 to infinity of 1 over k minus 1 over k plus 1. And you recognize that this is just a telescoping series. So we're going to have a minus pi squared over 6 plus 1, and then plus, we're going to have a 1 minus a half plus a half minus a third, and plus a third minus a fourth, plus 1 over n minus 1 minus 1 over n plus 1 over n minus 1 over n plus 1. So negative a half and a half cancel, negative a third and a third cancel, and so on. And we just had to take the limit of the partial sums. So we're going to have a negative pi squared over 6 plus 1, and then plus the limit as n tends to positive infinity of 1 minus 1 over n plus 1. But evaluating that limit, we just have a minus pi squared over 6 plus 1, and we have a plus 1. So this is equal to minus pi squared over 6 plus 2 is equal to 2 minus pi squared over 6. So now we could say that therefore the integral from 0 to 1 of 1 divided by 1 plus the floor of 1 over x dx evaluates to 2 minus pi squared over 6.